Okay, so now we will be talking about the second sample of our final exam. So the first problem here is actually giving us force F1 and F2. So we are supposed to find out the magnitude of y vector R, which equals to F1 minus F2. Okay. So so given F1 and F2, what would the R equals to F1 minus F2 looks like? Well, it will be a vector from the head of F2 to the head of F1, right? Okay, this is actually our R. Well, another way to understand why R looks like this is because given that R equals to F1 minus F2, therefore F1 equals to R plus F2, right? So if you look at the triangle here, and by triangle rule, we have the resultant vector equals to the vector from the start of the first vector, which is F2, to the end of the second vector, which is R here, right? It also makes sense from that perspective. Okay, so given that we have R here and we have F1, F2, R, they formed a triangle, right? They formed a triangle here. And now we are going to find out the magnitude of R. And how can we find out that? Again, so the magnitude of R, it is actually the length of R or the length of side R here of the triangle, right? If we denote the triangle as O, A, and B. Okay, so actually the magnitude of R is the length of a side AB, right? And how can we find out that? Again, it is trying to make use of law of cosine and sine, right? So the formulas is given in appendix and page 1 here. So at the very bottom of the page, and you're going to see that we have a law of cosines and a law of sines. Okay, so specifically, law of cosines is typically can help us to find out the length of the side. So that would be related to the magnitude of force. Well, the law of sines here is more related to, given that you know the length of multiple sides, and we can evaluate unknown angles, right? It is actually will be used in the second uh question here. Okay, so now by law of cosine, and we have the length of R equals to. Okay, actually, it is a more convenient to start with R squared equals to what? R squared equals to the length of OA, right? The length of OA plus the length of OB minus 2 times, okay, the product of the two sides, then cosine of the angle between OA and OB here. So the angle, suppose that we see it is here. Okay, so now we see that OA is actually, okay, OA is actually F2, right? So it is a 5 kilonewton here. And OB is F1, right? Which is a 6 kilonewton here. Okay. And we have a phi equals to, since phi plus 30 degrees and 20 degrees equals to 90 degree here, and phi equals to 90 degrees minus 30 degrees and 20 degrees here. Okay, so it equals to 440 degrees, right? And now we can proceed with OA equals to, okay, so we have those values substituted. Then phi, and phi here is a 90 degree minus 30 degree minus 20 degree is actually 40 degree here, right? And then we have r equals to square root of that, right? R equals the square root of that, and that would equals to. So we're going to have it a square root of 5 square, 6 square minus 2 times 5 times 6 times cosine of 40 degrees here, which is actually 3.88 kilonewton here. Right, it is actually the answer for the first question here. Okay. So now, so we see that actually when we are trying to find out the magnitude of force, it is actually to typically use law of cosines here, right? Law of cosines. So given that you know the length of the rest of the two sides and you know the angle between the two sides, and here's the phase, and you can evaluate the the length of the side. That's of your interest here. Okay. So now we move on to the second question here. It is asking us to find out the orientation of the force R here. Okay, so how can we evaluate that? Okay, so now actually to find out the orientation of that, typically we will have to have the Cartesian format of R, and to do it, we will also so we can express the F1 and F2 in its Cartesian format, right? So we have F1, F1 expressed in its Cartesian format here, which is actually, so the X component will be, and we have to decompose F1 into its X component, F1X and F1Y. Okay, so which equals to F1X and F1Y, right? And F1X equals to F1X equal, actually it is equals to the magnitude of the force times sine of 30 degrees, right? Okay, I plus, and then my y component is actually, so since my y component here is the adjacent, so it is a cosine 30 degree here. So that would equals to 3 plus, so 5.2 J here, kilonewton. Okay, so similarly, we can decompose F2 here as well into its X component and Y component. It is actually our F2X and F2Y. Okay, so actually our F2 here can be expressed as F2X plus F2Y, and F2X equals to magnitude times, since X component here, F2X is the adjacent, so it is a cosine 20 degrees here. Okay, so my Y component is the opposite, so it is times sine 20 degrees here. And you can go ahead and calculate that. It equals to, right? Okay, so now we have R equals to the R is actually defined as F1 minus F2, right? So F1 minus F2, and by Cartesian it is you have the corresponding components to perform the operation, right? So for my y component, so for my x component, it will be 3 minus 4.7. Like, so it is my I component, and my j component is actually it is 5.2 minus 1.7, and it actually equals to negative 1.7 I plus 3.5 J kilonewton. Okay, so now it is actually the Cartesian format of the y vector here. Well, so if we stop here, probably you already see that it is also possible to solve the first question by Cartesian form by Cartesian format here because we given that we have the Cartesian format of the vector r, you can evaluate the magnitude of the vector r, which equals to summation of the square root of the summation of squares of the components, right? So here actually you can also check whether the answer for your first question is correct or not. Okay, so now based on what we have here, uh, and we can evaluate the the orientation of the vector r. Well, if we visualize the orientation here. Okay, so the orientation of your vector r, it is actually equals to, suppose that we see that it's a theta here. So tangent theta will be the ratio between the ry and rx, right? So you are going to have theta here equals to tangent inverse of the ratio between ry and rx. And please note that here we have absolute y value here. Okay, so that would equals to tangent inverse of 3.5 divided by 1.7, right? Okay, it equals to 3.5 divided by 1.7, which is 64.09 degrees. And we also they note the orientation looks like this. Okay. So the answer is 64.09 degrees. Okay. Okay. So the first question here is actually examining our understanding of vector subtraction and expressing vectors and performing operations on vectors in Cartesian format here. Okay. Okay.